right, welcome back. We're going to talk about basic geometric figures. We'll talk about points, lines, angles, and some basic geometric shapes. We'll also get into measuring angles with degrees, minutes, and seconds. So just some basic little introduction here. Geometry, if you guys did not know, comes from the Greek words geo, meaning earth, and metro, meaning measure. So it's kind of the branch of mathematics that deals with spatial measurements, right? Measurement of the earth. And of course, architecture deals with a lot of geometry. A point, well, a point's just a small dot, right? It has no length, width, or thickness. A line simply connects 2 points, right? It's just between the 2 points. A plane is two-dimensional, has no thickness, right? So think of like a chalkboard, except a chalkboard with no thickness. That would be a plane. We can name a line with any 2 points. So you can say that as line AB or line BA. You can have a half line, like that second case. Notice it has half line A through B. This is not including A because it's open right there. Whereas a ray will actually include, filled in, ray AB, denoted there with that ray AB. And then finally a line segment just stops, right? It doesn't keep going. There's our line segment AB, or you can say line segment BA, right? So different ways to say that. An angle, we can name an angle in a multitude of ways. So we can say angle 1, using the 1 right there. We can also use the vertex. We can say angle B. We can also go from CBA, so angle CBA, you put that vertex in the middle, or you can go angle ABC. Again, the vertex has got to be in the middle if you do it that way, right? So those are 4 different ways to name an angle when we're measuring angles. So you can measure angles. There's different ways to do that. A geometric angle is simply how many degrees there are between there and there. Let's say that's 30 degrees. All the way around an entire circle, right? A whole circle would be 360 degrees around the entire circle, right? So 30 degrees would just be a little bit of that, all right, a 1/12 of that. So 1 degree is just one little 3/60th of that, right? 1 degree. So 360 degrees all the way around. 1 degree would just be 1/360th of that. Right? I can't draw that very well, obviously, but that's 1/360th of a rotation would be 1 degree. Now, we can measure angles to greater accuracy. So if you have, let me blow up 1 degree. Let's say I know I blew it up. I zoomed in really, really big. Okay, I know this looks like a lot more than 1 degree. But 60 minutes makes up 1 degree. So if you were to cut this in 60 times, for every 1 degree, it's equivalent to 60 of those minutes. Right? There's 60 of those cuts in there, if you will, make up 1 degree. And then every minute, again, that's the notation for minute here. For every minute can be split up into 60 seconds for a greater accuracy. Ignore this is incorrect. We actually do work with some seconds in this course. So they used to not, now we do. All right, let's do some examples here. So for example, 78.7 degrees, we're going to put that into angles and seconds. So, this is 90 degrees, right? So 78.7 would be more like this kind of thing, 78.7 degrees, but we want it in degrees and minutes. So what we do is we take the 78.7 degrees and we say, all right, that's 78 degrees plus the 0.7 degrees. Now the problem is the 0.7 part. We're okay with the 78 degree part. So we go 78 degree, but we got to convert this 0.7 degrees to minutes. So we say, well, for every 1 degree, there's 60 seconds. And of course, for every 1 second, for every 1 degree, there's 60 minutes. That's minutes. And for every 1 minute, there's 60 seconds, right? So we're going to go from degrees to minutes. We're going to use the top one. There's 60 minutes for every 1 degree. And now notice my degree units cancel. So I have 0.7 times 60. So this becomes 78 degrees plus, now I'm going to punch in 0.7 in my calculator times 60. 0.7 times 60 gives me 42. And I'm in minutes. So, and then I don't have any more decimals anymore. So I stop right there. 78 degrees, 42 minutes, and I'm all done. Okay. Do another one here, 95.3 degrees. So now, oops. Yeah, we've got an angle like this kind of thing. 95.3 degrees. Again, the 95 we're okay with. It's the 0.3 degrees that's the issue. So I leave the 95 degrees. I convert the 0.3 degrees to minutes. There's 60 minutes for every 1 degree. The degree cancels. So now we have 0.3 times 60. And we get 18. So then we write it 95 degrees, 18 minutes is the same as 95.3 degrees. Let me do an additional here, you guys. So I have about 32.479 degrees. So that's 32 degrees plus 0.479 degrees. So what I'm going to do is I'm going to take the 0.479 and I say, well, there's 60 minutes for every 1 degree, so the degree cancels. So I have 0.479 times 60. That gives me 28.74. And so I'm okay with the 32 degrees. Oh, I'm sorry, I'm not in degrees. My degrees cancel here. I'm in minutes. This is minutes. So I have 32 degrees plus 28.74. So I'm okay with the 28 part, 28 minutes. But now I got to deal with the 0.74 minutes. I don't like the decimal part. So I got to convert that. There's 60 seconds for every 1 minute. And now my minutes cancel. So I have 0.74 times 60, which is 44.4 seconds. So what I have is 32 degrees, 28 minutes, and 44.4 seconds. And you can just round the last one. So 32 degrees, 28 minutes, round that 44.4 to 44 seconds. 0.4, so it doesn't go up, it just stays at 44. All right. All right, let me erase that. Let's go to the next one, 159 degrees, 15 seconds. All right, so this example, we're going to take the angles and put them as a decimal now. 159 degrees, and there's 15 minutes. So we want 159 point something is what we want. So we're going the other way. 159 degrees plus 15 minutes. Now remember, for every 1 degree, there's 60 minutes. notice my minutes cancel. Oops, gosh dang. Guys, I just realized, yeah, that's supposed to be a minute there. Now the minute cancels there. Every 1 degree, 60 minutes. So I got 159 degrees plus 15/60 degrees. So I got 159 plus 15 over 60. Well, 15 over 60 is 0.25. So this is 159.25 degrees. So 159 degrees 15 minutes is 159.25 degrees. Let's do a couple more here. 127 degrees 36 minutes. 127 degrees 36 minutes. So 127 degrees, that's okay. 36 minutes got to be converted. For every 1 degree, there's 60 minutes. Notice my minutes cancel, so I have 36/60. 127 degrees plus 36/60 degrees. So I have 127 degrees plus, now I punch in 36/60, and I get 0.6 degrees. So 127.6 degrees. I do have one more. Let me do one with 65 degrees. Let me go 9 minutes 17 seconds. So let me do the seconds as well. So we have 65 degrees plus 9 minutes, which we got to convert to degrees. And we have 17 seconds, which we got to convert to degrees. So 65 degrees, okay. 9 minutes, so we know that for every 1 degree, there's 60 seconds. So we have 65 degrees plus 9/60 degrees. And now we got to deal with this 17 seconds. Well, for every 1 minute, there's 60 seconds. So now I'm in minutes. But I got to convert my minutes to degrees. So for every 1 degree, there's 60 minutes. And now notice my minutes cancels. So this ends up being 17 times 1 times 1 over 60 times 60, which is 3,600. But now it's in degrees. Let me get rid of this right here. So I have 65 plus 9/60. Well, 9/60 is 0.15 degrees, and then 17 over 3,600 is 0.0047222. So I add 65 plus 0.15 plus 0.00472 repeated, and I get 65.15472 repeated degrees. And then you can just, you can round that to whatever you want to round it to. But we're right there. Okay, so that's a little bit on degrees, minutes, and seconds. And let's get into classification of triangles. An isosceles triangle has 2 sides the same. So notice the marking here and here. Those sides are the same. So if this is 3 inches, that would have to be 3 inches. And that also means that they have 2 angles that are the same on opposite sides. So maybe this is, I don't know, if that's 50 degrees, this has got to be 50 degrees right there as well. Now an equilateral triangle will have 3 sides that are the same length. So if that's 4 inches, that's 4 inches, that's got to be 4 inches, which also means all 3 of the angles are the same. So 60, 60, 60. And the 3 angles, all 3 angles in a triangle will add up to 180 degrees. So those would have to be 60 degrees each, because 60 plus 60 plus 60 is 180. A scalene triangle just means no sides are equal. If that's 2, maybe that's 3, maybe that's 5 or whatever. But none of the sides are equal. That's a scalene triangle. A right triangle has a 90-degree angle right here, so that's 90 degrees. And the legs of the triangle A and B, the sum of the squares of the legs will equal the square of the what's called the hypotenuse. The hypotenuse is the side opposite the 90-degree angle, right? That's a property of a right triangle. A little bit more here with some characteristics of some four-sided. A parallelogram means we have opposite sides are parallel, right? So this side parallel, this side parallel, right? And so the opposite sides will also have be equal in measure. A rhombus is a parallelogram, but all the sides are equal lengths. So opposite sides are parallel, but not only that, so left, right, and top, bottom, but they're all equal in length as well. So it takes the parallelogram a little further, the rhombus does. A rectangle is a parallelogram. In other words, the opposite sides are parallel, but in addition, it has 90-degree angles, right, in all four corners. A square is a rectangle, but all sides are equal, right? So if that's 4, that's 4, that's 4, that's 4. All sides are equal, and you've got those 90-degree angles because a square is a type of rectangle. A trapezoid is a quadrilateral with only one pair of sides parallel, so that top and bottom here are parallel. Only one side of the trapezoid would be parallel. Okay. A circle is simply a set of points that's all equal distant from a given point in the center. So if this is our center, and every point's the equal distance from there, and you plot every one of those points, right? You plot them all, soon enough it's solid, and you've got your circle, right? And this distance here is our radius r. The diameter is all the way across. That's our diameter. So 2r is our diameter, double the radius length. And let's go ahead and find the radius for this example right here. If the whole diameter all the way across, if it's 40 yards all the way across, then what would the radius be, which is just half that length, right? So the radius, if diameter is 40 yards, the radius must be half that, half the diameter. So half of the 40 yards. Half of 40 is 20. So the radius would be 20 yards in this case. Anyways, I think that'll kind of get you guys started. Appreciate you watching. See you next time.